The main objective is to have equipment here that will be able to record the level of acceleration in case of an earthquake. So the equipment will not monitor constantly the level of acceleration. They will only record, let's say, the time series of acceleration in case of a moderate to strong earthquake happens in the region of Lisbon. So those time series that will be recorded will then be transmitted to the municipality, and then based on the level of acceleration, they will decide if there's a need to have, let's say, a team here to make a survey of the building to check if there is some kind of non-structural or structural damage that may limit the functionality of the building. Although the school is technically one building, it's made of 4 structurally independent blocks. So each of those blocks is independent from each other in terms of interaction during an earthquake. So we'll put one sensor in each of the blocks. The location that we selected for each of those 4 sensors is basically a function of 2 or 3 things. So the capacity to have Wi-Fi in order to transmit the information using the Wi-Fi system of the school, and then connection to the, let's say, the general network connects the schools to the municipality. Then the power supply. Ideally, those equipments, since they run on electricity, they will need to be more or less close to energy supply source, or they will have to have a battery, a rechargeable battery. And ideally, they should be located as low as possible with respect to the ground level. In this case here, there's some limitations because most of the ground level is outside. But since the structure is very stiff, a very strong structure, we will put it on the first floor in most of the cases, and ideally that will not be a main issue. So we can say that what we'll record on the top floor or the first floor will be more or less what we expect to happen in the ground. So in terms of resilience, if we think of resilience of this wider concept that includes prevention, response, and recovery, this specific activity here is more dedicated to that response and recovery. So if you have the capacity to say, oh, this building is sound, is safe after an earthquake, based on information that we can capture from these sensors, ideally this building can serve as a shelter or temporary shelter for the local communities. And if those communities are hit by the earthquake and their houses becomes excessively damaged, this school can serve as a shelter. And the decision to make this school as a shelter needs to be quick after the earthquake. So the faster we can make this decision, the better. So if we have information that tells us exactly what happened in terms of acceleration due to an earthquake in this school, the sooner we can make a decision to say, okay, we can dispatch some people to the school to see if it's damaged or not, or the level of acceleration is low enough that we can be sure that the school is not damaged and can be reused as we want. The Faculty of Engineering of the University of Porto has a long track record of working and doing research and consultancy in the field of earthquake engineering, and in particular fields of prevention, mitigation, vulnerability assessment. So there's a long history of that. I mean, we have a large group that works on this topic for a long time. Cooperation with outside institutions, namely other universities or even municipalities. So within that context, we have a strong connection with the municipality of Lisbon in other research projects, in specifically with the municipal program Resist, because we are consultants of that program for the past 5 or 6 years. And the activities we're doing here in this project with Discute is exactly on the same topic, so increasing resilience of the built environment. So what we are doing here in terms of installing these sensors in this school will ideally be replicable in the future to other schools in Lisbon, ideally within the scope of what Resist will implement in the near future. These activities per se are more than research, they're applied research. They're not just trying to solve a problem from a conceptual point of view, but trying to solve a problem from a practical point of view. And this connection with municipalities is essential for that, because in the end, I mean, those are the people that will be using these equipment and using this research and these outcomes. So we are strongly committed to this type of approach, this applied research approach. And we welcome other projects like this to be involved in the future, and we welcome your involvement with the schools and the municipality.